Hello and welcome to another video from the vault, where we listen in on a classroom lecture and see what there is to learn. Today is a long one. It's on general problem solving. Take lots of breaks and have fun.
In general, of course, I'm not going to show it on the screen, but it would have made it a little easier. In any case, we're talking about general problem solving. Now, that's a very big topic that can cover a lot of things. Whenever you have a problem, technically, that you want to solve, general problem solving. And because of that vagueness in the topic title, there's a lot of difficulty and range in difficulty that you can encounter in a question. One question can be trivially easy, and the very next one can require a little bit of work. And there's really no limit to how complicated it can be. Now, for us, there is a limit, of course. But even within this course, the difficulty in the questions can range from very easy to challenging, I'll say. Not impossible, just more challenging. But regardless, I want to... There are many sort of strategies and thinking strategies that I can keep in mind as I think about problem solving. One that I've encountered, I remember in my fourth year we were given some office space with a computer, and whoever was there before me had a little sign on the desk with the 4 words. And for some reason, it stuck with me. Only, ironically, like last week that I realized it spelled step. Never occurred to me. Like, oh, that's handy, step. What can I say? So, we can think of it as the steps in problem solving. Of course, we're not talking about a specific kind of problem, it's all general, so the steps are vague as well. But it's kind of cool that it spells step. I never saw that before. And we're talking like years. Never occurred to me. Oh well. Now I'm not necessarily going to write all of it out because it is in the book. The first thing that is dangerous when I encounter problems is that I bring in my own assumptions. And I read things that aren't actually there. And I have to be aware of that. And you'll see kids do that all the time. They think they're reading something when that's not actually what the words are saying. So I have to practice that within myself as well. So just stop. Read the question for what it is. And don't read more or less than what there is. So yeah, just a general stop. And let's start fresh. Don't expect the question to be difficult. Don't expect it to be easy. It just is what it is. So we just stop. I guess my arrow should go this way. Now we're talking about this one. Next, think about what the question is linked. Think about what the question is saying. The words that it's using, evaluate those words. Don't read between the lines. Don't try and make it more complicated or less complicated. Think about what it is saying. And no more and no less. Then, evaluate. It can mean many things. In my mind, it means let's evaluate the question and come up with a plan. Make a plan. Without a plan, we can't move forward. Make a plan. How are you going to approach this question? It's not necessarily going to be the right plan, but it is a plan that you can move forward with. I remember in the second year math course that we had a tutorial which we were given a list of questions and we had to work through them once a week. And the first tutorial We had no idea what was going on. No idea what to do, so we just sat there with the questions, not really knowing what to do. And the professor said, don't think about it, just start writing, and it'll sort of happen naturally. And I remember looking at him and thinking, that is the worst advice you can give me. I'm not writing an essay. I'm doing something technical and specific. You can't just start writing without a plan and just go, well, the universe will guide me. It just doesn't work. You could get lucky, but it's just not going to work. You have to have a plan. Whether that plan is going to lead you to the correct answer or not, you have to have a plan. And then you proceed with that plan. If you write an essay, yes, sometimes you just start writing and it sort of goes in a direction without you necessarily planning that direction initially. That's fine, but that's not what we're doing here. We're doing mathematical thinking, scientific thinking, and we want to be precise and have a plan before we start doing anything. And that plan is dependent on my understanding of the question. And then after I make a plan, I can proceed. Now this loops back. That maybe my plan wasn't the best plan ever. It was a plan, so that's good. It doesn't really matter if it's the best or not, or perfectly correct. It was a plan, and I executed the plan, I proceeded with the plan, and I realized after checking an answer that I get, maybe looking back at the question, it wasn't actually correct. Then I go back, stop, think again, what's the question? Did I actually answer that question? Were I on track? Did I understand it correctly? Maybe I have to update my plan. So make/update. As I understand the question better, and then proceed, and eventually I'll get to the answer. But that's very vague in general, as it should be for general problem solving. We have some examples in 3.2, strategies for typical kinds of problems that we could encounter. Of course, there's a lot of strategies. And if I scan through them, I'll see it from make a table or list, work backwards strategy, a smaller problem, maybe a sketch. I can ask another question first before answering the problem. There could be trick questions. There are some classic problems that I should see. Inductive reasoning in point 8. And there's a pattern that I could notice. Trial and error, guess and check. That's also a valid strategy. Limited, but sometimes it is the valid strategy. So there's a variety of strategies that I could incorporate. Now, I'm not memorizing these all. I just want to be aware of my options. I have a lot of options, and there could be others that aren't on the list. So we have examples, sometimes one, sometimes a couple, to illustrate each of those strategies. And our goal for the next, what I think could be 3 days, will be to just go through them, just see some variety, see the variety in this general problem-solving topic that you can encounter, and the tools that you have, the ways of thinking that you have to approach those problems. Because in a test, they're not going to come with a heading, oh, I should work backwards, I should make a table. You have to know. And there isn't necessarily one answer. You think about the question, you make a plan. Maybe your plan could be make a table, and then you realize, oh, maybe that wasn't the most efficient way for this question. You go back and you try something else. So, example 3.1. Now we know the heading it's under, make a table or less, so I know the strategy that I'm going to do, but eventually we have to come up with the strategy ourselves. And in the additional exercises, it's exactly like that. You don't know the strategy you're supposed to use. So it's a nice crossover before the quiz. When is the quiz? Monday. It's Monday, isn't it? Yeah. But the good news is we have 2 tries, so it's all good. Nothing to worry about. Anyway, exercise 3.1. How many different 4-digit numbers have the same digits as 1987? So I have to make sure I understand the question, of course. Understanding the question is key. You cannot move on. Even if reading that question 5 times is what's needed for me to understand the question, it's time well spent. I cannot be impatient and in a hurry at this stage. Now that's a very straightforward question. Some of them are less so, more wordy. So I'm trying to make as many different numbers as I can with the digits, and I'll put them in order: 1, 7, 8, and 9. And the only challenge here is to be systematic. If I just systematic in my making of the list, if I just randomly write down numbers, then I could very easily miss one. That's really the only challenge. Now, how can I be systematic to make my list? Well, I put them in order for one. Then the first one is going to be 1, 7, 8, 9. And again, this is just one way, not the only way, like you'll see with many of these examples. So what I could do then is keep the first 2 fixed, and then see all the ways I can shuffle the last ones. So I can have a 1, 7 again fixed, but a 9, 8 instead. With the 1 and the 7 fixed, those are the only possibilities. So I'm making it a little easier, just shuffling 2 numbers at a time. So then I can't have a 1 and a 7, but I'll keep the 1, and then go for the next biggest number in position 2, which will be an 8. Fix that one. Then I have a 7, 9, or a 9, 7. And this way I'm making sure that I'm not missing anything. There's no randomness to my list. I have a specific plan for a way to work through them. I start with 1 in the first position and then see all the possibilities. With the 7, 8, and 9 numbers, I can fix one of them, swap the other 2, next one, swap the other 2, next one, swap the other 2. Does that make sense? Again, not the only way, but a sound strategy to make sure I get them all. What is next? So now I've made sure that I've gotten all the numbers, all the sequences, let's call them, with a number 1 in the first position. That's everything there is. So then I can go and say, okay, well, something else can be in the first position. And I'll fix that one, shuffle all the rest. So I'll have a bunch of 7s. Now I have a 1, 8, and 9. Fix the 1 and swap the other 2. Then the next one in position 2 could be an 8. Swap the other 2. And the last one in position 2 could be a 9 and swap the other 2. Any questions on what I'm doing? It is Monday. It's not that early, luckily. Next semester I have an 8:30 class. That's not going to go well. As the sunrise comes earlier and spring comes, it gets easier. But January is a tough one for an 8:30 class. Any questions? Comments? Am I done?
Could be.
It could be if I wanted to.
There's maybe a pattern.
Have I found? Well, yes, fair enough. The question is only asking how many there are. But for the sake of being 100% certain, let's complete our list. That's really an issue that will come up in 143. We'll leave that little gem for later. So for now, we want to complete the list to be absolutely sure. But you're right. There is a pattern you can see. Yeah. Really, I'm using this question to learn making that list more than finding the answer. So what else could be in position 1? 8 could be in position 1. And there could be a bunch of them. Clearly the same number, the same amount as these, which were 6. So 8 could be followed by a 1, then 7, 9, or 9, 7. Could be followed by a 7, then 1, 9, or 9, 1. Then it could be followed by a 9, or 1, 7 and 7, 1. Clearly there are 6 more with the 9 in position 1, so we might as well finish them. It's not, it's not only finding the number, that is what the question is saying, but also how did I find it? Might as well finish my list and have closure. 1, 7, 8, 1, 8, 7. 3 numbers are easier to shuffle than all 4 at once. So I fix one number and make my job easier. Then a 7, 1, 8 and a 7, 8, 1. 8, 1, 7, 8, 7, 1. And from that list, the way I've made the list, I'm sure that I didn't miss anything. At every stage, I've considered every possibility. So I'll write it up here. There are 6 times 4, 24 different, let's say, ways to make my number, to arrange the digits. And in all these problems, well, not all of them, almost all of them, wherever possible, I want to end with what I call a concluding sentence, saying this is my answer. Especially in a test, maybe your calculations are all over the place. Just wrap it up and say, here's my answer, look at this. So that my question, my answer wraps up nicely. Yes?
Is it 23 or 24? Because do you include
Did I miss one?
Oh, no.
Oh, yes. So again, that's a good one. Should I include the original number? You could probably read the question in that way. How many different 4-digit numbers have the same digits as 1987? That's a number. Where is 1987? That one has the same digits as 1987. So it should be 24, yeah.
Okay.
Otherwise, it would have had to say how many other numbers or something like that. But it's good. You have to read the question carefully. And you could interpret it multiple ways, I suppose. Yeah. So in a test, if that ever happens, feel free to clarify what exactly are they asking for here. If you're ever confused. I can definitely help you clarify the question. That's not really revealing the answer or doing it for you. Then they have a little sub part, and we're in no hurry. This is the only thing we have to do left. Only thing we have left to do, and then quiz time. So there's more than enough time in this week for review as well. What if you had the numbers 1977? What happens then? So take a minute. It's all fun to sit back and watch me do everything. But in the interest of preparing for an eventual test, you want to start thinking about it yourself. Can I adapt this, and how does it change if I had 1977? You don't have to finish the answer, you don't have to do the whole thing, I just want to think about it, at the very least. And I'll start doing it in the same way, and see what the 7s are doing as we go. Remember, those two 7s are now identical. So swapping them doesn't create a different number. We are rolling in time, so it's good to take a minute and just think about how you would do it. You don't have to do it perfectly right now. So let me ask this. I put a 7 in position 2, similar to my previous strategy, and that 7 is here again. Does it make sense to now put the other 7 in position 2? No, it's the same. You can't tell the difference. So I'm only going to put a 7 in position 2 once. And the next one will be a 9. Oops. Can I swap those 2 7s? Create a different number? No, they're the same. So my options are more limited this time. So then I go to the next one. 179, 197. Here I have a few more options with the 7 in position 1, then a 1, or another 7, or a 9, but again, notice that having a plan and executing that plan makes a huge difference. So what have I done so far? 7 in the first position. So the only thing that's left is a 9 in the first position. This is on camera, it is. Following that system, that plan, which one would be next? So say again?
9771.
9771. Is there anything missing? So I start with a 9, I start with a 1, and then I have to have 2 7s. I can start with a 7, and then it's 1 7 or 7 1. Is there anything missing in that list? Is that the same list you got if you finished it? You don't have to finish it. I kept talking and distracting you, so how could you? Let's see how many we got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 different ways. You'll see that if you have a question like this to little Timmy, it's very challenging to convince him that the list is complete. Very challenging. I don't have any secrets for how to do that. There is some insight, yes. The best you can do is have a systematic way. Well, is there anything else with a 1 in front? No. Is there anything else with a 7 in front? Yes, there are more of them. There's nothing else with a 7 in front. There's nothing else with a 9 in front. Therefore, there's nothing missing. That is a logical reason. That is a form of logical reasoning. That's a logical argument for sure. If you've considered all the possibilities, then there's nothing missing. Any questions or comments on that? So making a list is certainly helpful because in this case, it wasn't a nice setup like this with equal sized groups. The 1s in front were only 3, the 7s had 6, and the 9s had 3 again. So I don't want to see more than there is right now. Yes, there is more going on here. But for us now, it's only making a list. That's important. I'll read the next question, perhaps. And then you can think about it while I explain. 3.2. After completing the repairs on an elevator, a maintenance engineer tested his work by sending the elevator up 12 floors, down 18 floors, and back up 20 floors. If the elevator ended up on the 30th floor, on which floor did the engineer begin his test? Or her test? So the title says working backwards, so I guess we can do that. And often, regardless of what the specific plan is, making a sketch makes a big difference. Just visualizing what's happening. So yes, we're not in the draw a sketch subsection, but that doesn't mean you're not allowed to draw a sketch. I want to draw a sketch right now. So I'm going to. So, let me keep this in front of me, a little bit easier. So they end up on the 30th floor. Let's say 30 is over there. 30th floor. What happened before that? Getting to the 30th floor, what happened before that? Well, working backwards, like the title says, he went back up 20 floors. So he went up 20 floors, so he must have been on the 10th floor. How did he get to the 10th floor? He went down 18 floors. Let's put it over here. Went down 18 floors. So that means he would have been on the 28th floor. How did he get on the 28th floor? He went up 12 floors. That means he would have come from the 16th floor. And that is all he did. So my answer is right there. My concluding sentence with the diagram is really all I need to do. He started on the 16th floor. The diagram can serve as my answer. There's nothing more I need to do because I showed this is the end position. So this has to be the start, working backward. Any questions on that? It's too easy? It's fairly easy. Yeah, it's nice. See an easy one now and then?
Sorry, do you need to do the diagram, or could you just do like?
No, you have many options.
Could you do it your own
Yeah,
way, as long as you do it backwards?
As long as, no, not even.
Or you could do
As
it
long as you're explaining what you're doing and it's something that anyone can follow when they read this, it's all good. I'm just doing it backwards to illustrate this strategy. But no, that doesn't mean, so I shouldn't feel restricted to one strategy. Often there are multiple strategies. This one technically is draw a sketch strategy as well. And you have multiple ways of solving and explaining the question, whatever feels best for you. 3.3. Bob Zwettler goes to the racetrack with his buddies on a weekly basis. One week he tripled his money and then lost $12. He took his money back the next week, doubling it, but then lost 40. The following week he tried again, taking his money back with him. He quadrupled it, and then played well enough to take that much home with him, a total of $224. How much did he start with the first week? So, when you read that, with a little bit of practice and experience, it should definitely be a work backwards strategy, to me at least. We just have to keep track of it in a clear way. So maybe a table could work here. Could work. So let's say start of week, and how many weeks start do we have? Well, he started the very first week, and how many weeks? I lost track of it. See, I have to read this again. So I'll show you that. 1 week he did something, and then he ended that week with a certain amount. So let's say here, start of week, here's my numbers for the week. Week 1 starts, week 1 ends with a certain amount. So here will be dollar amounts. That's my choice. Doesn't have to be the only choice. He went back the next week, so there is a week 2 that he started with a certain amount. I'm just making my plan. Trying to understand the question. And then he ends that week with a certain amount. Following week he tried again. So there is a third week that he's going to start with some money and end with some money. Is everyone happy that there are 3 weeks and things happen? Going in 1 week with money, coming out the week with money. So that's my choice for structuring my answer and explaining and keeping track of everything. If I just start writing things down, it's hard to keep track of everything. I can very easily miss something. So I'm trying to help myself. And in that process, I'm helping the presentation of my answer as well, helping the reader understand what I did, if anyone wants to read it. Or if I read it months from now, studying for the final. It can't be just scribbles. I'm going to spend like half an hour deciphering what I did, and that's inefficient. I want to remember what I did and move on, and learn from it, and refresh my memory. So, I have no idea what he started week 1 with, but I know what he ended with, 224. So definitely working backwards seems like a good plan. And now I'm going to proceed with that plan. So backwards, how did he get to 224?
Quadrupled.
He quadrupled his money. That's the only thing that happened in that 3rd week. He went back, he quadrupled his money, and he took that much home. So how do I, not what is the starting amount, how do I determine the starting amount of that week? Divide by 4 to get 56, she says. Everyone happy with how she got 56? So there's a difference here, I should say, and emphasize that there's a difference between doing and answering these questions correctly and being able to explain your answer. As most of us are thinking about teaching, you can't be happy with just being able to do it. You have to be able to explain everything. So it's the same as the logical reasoning. Stop at any point. Can you explain? Why did I write down this 56? How did I do it? Imagine you have an audience and you have to explain everything. You get some people, and I've seen them, that are really good. They can solve many things, and quickly, but they can't explain very well how they did it. They're not as aware of every little step. And we have to be very aware, yes.
Would just like making an equation be enough?
I'm trying to avoid equations on purpose because it scares people. So we're building that up. In the very end, we'll have some equations too. I'm trying to have a non-threatening solution. But of course, again, it's not the only way. If you're comfortable with variables and equations, you can throw them around, absolutely. Well, she's near falling asleep, so I can't risk it. Dangerous game, variables and equations. And think about your audience. I can explain this to grade, well, they need arithmetic, right? 4? 4 or 5? And they have no idea of variables. Okay, maybe just a little bit. They have no idea really of equations and anything like that. So if you're limiting yourself to that strategy, you have to wait until all that knowledge is built up. And it's not necessary. They do introduce the notion of a variable and unknown very early, but it's not enough to handle this. Anyway, so he started week 3 with 56, so he ended the previous week with 56. Now, how did he end, or what happened in week 2 so that he could end with 56? I have to look at the question. Excuse me. He took his money back the next week, which was week 2, doubling it, and then lost 40. So there are really 2 steps. And you can highlight that by saying, what should we call this, before we get to the end? what should we call this in between? What do you want to call it? Two things happened. He doubled, then he lost, and that's how he got to the end. And by adding this column, I can make it a little more clear. What should we call it? Do you have any strong feelings what we should call that in-between column? No strong feelings? No?
Maybe like money lost and gained?
It's a little specific. Whatever you want to call it. You have to call it something descriptive. I don't know what to call it. Doesn't matter. Just to make our calculation easier. So I know here we 224, there's nothing there because only one thing really happened. He quadrupled his money. Okay, there's no in-between calculation I need to perform. Here is then a 56. So now there's a two-step calculation. The first thing that happened was doubled. So doubled would mean times 2. And then lost 40. So looking at it that way, I'm making my life easier. More detail, more little steps, that makes the whole thing easier. So here, if he lost 40, he had 96. I'm going slow on purpose. For some of you, these things are easier, and this isn't the hardest question. You can do it really quickly. But we're also thinking about teaching this question, teaching someone else, explaining what you did. Then he doubled it to get to 96. That means he started the week with 48. That means he ended the previous week with 48. He's moving in the right direction. Then what happened in the first week? 1 week he tripled his money. Tripled. And then lost 12. So it's very similar to the previous, to the second week. Very similar. So if he lost 12 to get to 48, that means in between he had 60, and he tripled his money to get to 60, so therefore he had 20. So you went from 20 to 224. That's not bad. It's not bad luck. I'm going to squeeze it in here. So let me now. Often before you write the concluding sentence, double check the question, and if you're actually answering what they are specifically asking. How much did he start the first week? Okay, I am. So he started the first week with $20. And clearly I'm saying what I did here, working backwards. I have the whole table of every little thing. You can double check it to see if he started with 20, does he in fact end with 224? If he does, then you're correct. Again, not the only way, but a non-threatening way, without any fancy math involved. I'm going to jump around a little bit, and I'm going to jump to 3.2.9. Actually, yes, 3.2.9. Look for a pattern. So the example that we're looking at is 313. 313. That comes in three sub-questions. Part 1 is very nice and simple. Determine 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7. Nothing to it. Add them together. Hopefully you don't need a calculator. Just do it in your head. What do we get? 28. It's a nice little warm-up question. But then, obviously, if we keep going with this for too long, doing it one plus the next one plus the next one is going to be tedious and way too time-consuming. So if I have something like number 2, where I go all the way to 100, I can't even write all of them. So I use 3 dots when I see the pattern. It goes up by 1 every time, and then maybe the last few to indicate where I stop. Now the question is, what do we do with that? If the pattern is the same, it just keeps going for longer. Now you could add them one at a time. How long do you think that would take you? I don't know. Assuming you didn't make a mistake, I don't know, 5 to 10 minutes? No one wants to do that. So we're going to have to be a little more creative. One thing that we can do is write the same list but backwards underneath. So this will be a 3, a 2, and a 1. Now, instead of adding up everything, I'm just going to add up these 2 numbers. And I'll get 101. That's pretty easy. I'll add up these 2 numbers, and I'll get 101. These 2, 101. And I keep going like that every time the pair gives me 101. So, wouldn't it be easier if we add up all these 101s instead? Why would that be easier? Because they're all the same, and repeated addition is multiplication. So let's do it over here. Long equal sign, because I'm running out of space. So first of all, if I want to convert repeated addition to multiplication, I would have to know how many of those 101s there are. So how many 101s are there? Then you say 100. Because the first one, second one, third one, 98th one, and 100. There are 100 of them. Let's write it out. There, oops, I don't like 19. There are 100 of them. So the number that we're adding over and over and over is 101. How many of them there are, that is 100. Therefore, if I add up all of them, I'll get 100 times 101. Repeated addition is multiplication. Everyone happy with that? Yes?
I have a question.
Sure.
Okay. So we're just doing like 1 plus 2 plus whatever. But then you added a second
We're
one.
changing the question now because we notice it's too tedious to just count this directly. So let's notice a pattern by shuffling things around, adding more things than we actually want.
Yeah, so then by adding a second line, are you doubling the amount then?
That is now the issue. How does this answer relate? This is not the answer to the original question. How does it relate to what I'm actually trying to find? It's double what I'm trying to find. But it was much easier. So let's write that here. This is double the answer to the original question. Double. Does everyone see that it's double what I'm originally looking for? But that's not a big deal. I'll do it over here. So the answer to the original question, let's give it a name. S for sum. Let's call this big S, just so we can name it and talk about it. So then I can say, I'm looking for that big S, which was just one of those top, just this top row. That's what I'm looking for. Let's give it a name, just so we can talk about it. If my answer here is double this, how do I find the value of big S? Divided by 2. What do I get? 50-50. So before we do number 3, let's put a pin in number 3 and look at exercise 314 that gives us some variations. Let's do that. And then you tell me, what you're seeing, is it still as convenient that you can do this half of this and use that instead of these two numbers? Maybe the answer is yes. Let me know. Let's see. So there's a lot of variations that we could do. 314. We'll come back to number 3 eventually. Right now we're looking at specific examples, and number 3 is only looking for a general formula, generalizing this pattern that we see. So this one, 2, 4, 6 to 100. So again, this is the sum that I'm looking for. 2 plus 4 plus 6 plus, let's go 98, and then 100. You don't have to write the second to last and third to last number, just the last one. So I want at least 3 of them, dot, 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 because the pattern should be obvious, and then where do I end? So now, can we exploit this pattern and technique that we saw here with the fairly simple 1, 2, 3, 4, 5 to 100? And something like this. So I try the writing backwards. 98, 96, and then I have a 4 and a 2. You seeing from on camera? Yes. Okay, just writing it backwards. Then my strategy, I'm just repeating the same strategy, seeing if it works. What are the differences? Do the shortcuts that I may have seen still apply? All those things, right? So now when I add them up pairwise, I get 102, 102, 102. That makes me feel good. It means I'm on track. It means this could work. Put some pluses between them. All right. Now with the, let's call it the basic strategy, no shortcuts, other than this is already a huge shortcut, but whatever. How many of these are there? How many 102s? 50? Does everyone agree with 50? All right. There are 50 of them. And I'm just writing it out so that when you look at it again, it's all there. Words help me remember and figure it out when I read it. So I'll do it over here. So, what should we call it? Let's call it, this is S as well. And we know this is double, so let's call it 2S. Why not? It is 2S. 2S, double, what we're looking for. So, now, because of our repeated addition, we counted there are 50 of them, therefore, this double sum is 50 times 102. And therefore, the sum that we're looking for is yet again 50 times 102 divided by 2. Number 2 in 314. Oops, I should probably turn the camera. I haven't forgotten once. One of these days I'm going to forget. It has 20 plus 21 all the way to 40. Let's call it S again. It's the same kind of problem. 20 plus 21 plus, I'll go one more, 22 plus, what's the one right before, 40. Because I know I'm going to flip things around, I might write a couple at the end as well. So now I'm starting to see that if I flip it around and add them up pairwise, I get the same number every time, then I'm on track. The strategy will work. If they're all different numbers when I do that, then I haven't really benefited from the repeated addition. But I'll try that again. 40 plus, then flipped around is 39, then 38, then 21, and the last one was 20. So I add them up pairwise. I'm hoping my strategy would work. Pairwise, I get a 60. Then I get 60 again. It feels good. I'm on track. Is this 60 as well? Yes, it is. And yes, it is. Okay. So when I see all of those the same number, then I'm feeling fairly good about that. Okay, so now the question is, like before, how many of these, and now there's 60s. How many 60s would you say there are? 40?
20.
Oh, sorry. I think you said 20. Yeah, sorry. At my age, the hearing is the first thing to go. At least I think that's what they're saying. I can't hear it. Someone got it. It's not Monday anymore. Tuesday. Okay. She says 20. Is everyone happy with 20? Or are you feeling something in this area? It could be breakfast, or it could be the 20. No, you feel nothing? Your breakfast is perfect? All right. Let's think about making a little table. Let's squeeze in my table over here. What I'm going to do is I'm going to count by way of a position this first sequence. So I have position and then the number in that position. So the numbers were 20, 21, 22, I'll do a few more, 23, all the way down to 40. Right? Can everyone see this 40? Should I move over there? It's a little low. Yeah. Let's go over here. Nice and high, because it is a little important. Just a little bit. So let's do it over here, which means I have to turn the camera. There we go. Okay. So I'm going to have a position, counter, and I'm going to have the number that occurs in that position, just the top row. So the numbers are 20, 21, 22, next one will be 23, that should be enough. That's one more, why not? And I'll stop at 40. Those are the numbers, right? By having a little counter, it's another way of counting how many there are. That 20 is the first one. 21 is the second. 22 is the third. And I'm trying to find out what is the counter for 40 that would answer that question. Is everyone happy with that would answer the question of how many? If I just keep counting, it would tell me how many there are. So 20 is in position 1, 21 is in position 2, 22 is in position 3, position 4, position 5, position what? That's what I'm looking for. That would answer the how many question. First, are there any questions about what I'm doing? That's what the answer is. It's what I'm doing. And why I'm doing it. Because my breakfast isn't sitting quite right. And I'm not sure if it's the 20 that's upsetting me. Not sure. So double checking. This is a very handy thing to have just when you need it as a double check. Okay, so how do I determine this guy? Well, what I need to do is I need to find the link between the position and the number. Position and the number, position and the number, position and the number, position and the number. And then I can reverse that link to find that position. What is the link between 1 and 20? Now, there are many answers. I'm looking for one that would work every time. How can I get from 1 to 20? What can I do? I could add 19. Would it work getting me from 2 to 21? It does seem to work. Would it work from 3 to 22? 19. I'm looking for one pattern, right? It has to always be the same. And this adding 19 seems to always be the same. Getting from 4 to 23, getting from 5 to 24. So I think we have a winner. Adding 19 is the link between the position and the number in that position. Does everyone agree with that? So that means that whatever this question mark is, if I add 19, I have to get to 40. Therefore, the question mark has to be 21. Meaning there are 21 of these 60s. Luckily, it wasn't my breakfast, it was a 20. The answer is not 20, 21. A little table like that, very convenient. Sorry?
You have the same difference.
You have to have the same link, and in this case, it's a difference, yes. In 143, we'll see more that aren't always differences. But in this case, it's actually for the counting positions, it's often just a difference. Yeah. It has to be the same every time. So a common mistake is to look at this and say, oh, there are 20. But no, there are 21. That little table is very handy. I really like this table. When you're trying to count things, it comes up often as a convenient way to figure something out. We're not really done. This was an S. This was still a double S. So now we have this double sum is therefore 21 groups of 60, which is multiplication. And so the sum that I'm looking for is 21 times 60 divided by 2, because it's double what I'm looking for. This is why I was concerned with the shortcut before. Because now what do you do? 21 divided by 2? Timmy's surely not going to like that. And of course it depends on your audience, but I believe for most, doing the multiplication first and then arguing why you have to divide might be the easiest way to explain. Because it's not always an even number. But the answer is still a whole number. Let's go back to exercise 313, just to wrap it up, where we're not really doing anything new. Not really. The pattern was there. We observed the pattern. Everything's good. We're just stating the pattern in a more mathematical way, by way of a formula. That's all we're doing. So now, if you look at number 1, I ended in 7. I ended with 7. Number 2 ended with 100. We figured out how to work with it. But you can end with anything. If you go 1, 2, 3, 4, 5, and so on, you start with 1. You go 1 up every time and add them together. You can stop wherever you want. So now, in 313, number 3, we're stopping at any number, of course any whole number, let's call it n. Because you could say, I want to stop at 50, I want to stop at 30, I want to stop at 27. Who knows what that could be. So I want to leave it open, and you can put in any number you want. I want to find a formula where you can take your n number, plug it into the formula, and it would give me the answer. I don't have to go through this row, backwards, sum, count, every time. So now to do that, we have to do the strategy in general. So I stop at n. Am I on camera here? Yes. The strategy was, well, this was my s that I'm trying to find. I'm going to write s again, but backwards. So this is now the last number. How do I determine the one right before that? Minus 1. I'll put it in brackets because it's one number that's grouped with 2. And then this one would be minus 2. All the way down, and the 1 would be at the end. Then the strategy was add up the pairs to get an n plus 1. Now it depends on what that number is. I don't know what n plus 1 is until I know the number hiding behind n. Here, n minus 1 plus 2 gives me an n plus 1 again. I know they should be the same. It's the same strategy that we're using. N minus 2 plus 3 gives me a positive 1 up from n. And I keep going like this. It's always the same. N plus 1. Always the same. That's good. So now this is my double sum. Where can we squeeze it in? I'm going to squeeze it in here. So my double sum is, well, it's easier to count because I'm starting at 1 and it's 1, 2, 3. So the number is the same as the position. So how many do I have? How many n plus 1s do I have? N. Because of the simplicity of the sum, I can easily count them. There are n of them. So the double sum will be n times n plus 1. When we stopped at 100, n was replaced with 100, and the double sum was 100 times 101. But it doesn't matter where we stop. It has to be 1 plus 2 plus 3 plus 4. Any variation, and this formula isn't going to work exactly the same. So my sum that I'm looking for is then simply that divided by 2. I don't know what n is. N could be 51. Then n divided by 2 is not a whole number. And I'm just not quite comfortable with that dividing first. The dividing by 2 comes at the end. And I think that would make sense for most Vietnamese. Not that you're going to show them a formula, but with specific numbers. Does it make sense? I just want to sort of expose you to the idea of a formula and getting a formula. Now, this is the only formula we're going to do, but I do want to remember this. And it only works when I start with a 1 and the numbers go up by 1 every time. So it's very specific, but I just want us to see it. Yes?
In the question, it like states that the integer will be greater than or equal to 1. In the answer, do you have to like state that it won't be enough?
Technically, you should specify what n could be, but we're not going to get that fancy. We're just seeing something, using it a little bit, and then forgetting about it. We're easing into things. We don't have to be that technical, but yes, you should actually say what n can be. But it's the only formula that we're going to look at. Keep it casual and relaxed. Any questions on, so you don't have to derive this, just remember it. So if n, we squeeze it in here, if n is 100, then the sum was 100 times 101 over 2, which is what we got. But now I have the versatility to plug in anything. As long as the sum is 1 plus 2 plus 3 plus 4 to an n number. Any variation, and the formula is going to have to be adjusted. And I don't want to remember all those. I just want to be exposed to something like this. Any questions on that? Okay. Any questions? This is the most mathy we've been so far. I apologize. Back to section 3.2.3. Solve a similar, simpler problem. Exercise 3.4. Really, the only way to get better at problem solving is to look at many, many problems. See variety. To not get sort of funneled into thinking a certain way. That is the worst thing for general problem solving. Every question just has to be treated on its own with no assumptions coming in. But the difficulty that we're looking at is also not that bad. 3.4. "16 people in a round-robin tournament played every person once." So every person plays every other person. You can't play yourself. How many games were played? Now the strategy that I want to show here is that number could be big. The 16 people, that could have been a much larger number. And for large numbers, it's difficult to maybe figure it out. The size of the number can get in my way. So what's often very helpful is to do the same question, but just make a smaller number. So first, let's look at, let's say, 6 people. Instead of the 16, which could have been even more. Pick a manageable number that we can make a list for, make a drawing of, and all kinds of things, just more manageable. Let's look at 6 people. So now every person plays every person, how many games were played. So let's draw them over here. There's person 1, there's person 2, there's person 3, there's person 4, there's person 5, and there's person 6. 6 people. Easy, manageable, not intimidating at all. So now, we'll figure this out by way of a diagram. Sort of a mix, really. So let's say here, new people played by person 1. So right now I haven't considered any games. If I'm starting with person 1, they can play against person 2, 3, 4, 5, and 6. How many games? That would be 5 games. 5 games that I haven't counted yet. Everyone happy with the 5? Then I go to person 2. Consider all the games that I haven't considered yet. Person 2, I'm going to use squiggly lines. Can play against person 3, 4, 5, 6. They do play against person 1, but I already counted that game. So I'm not counting it again. New people that I haven't considered yet. So that'll be 4 games. Okay. Then person 3, I'll do curly lines. Person 3. Games that I still have to consider will be 4, 3 against 5, 3 against 6, 3 against 2 is already covered, 3 against 1 I already covered as well. So that's only 3 new games. When I consider person 2, how many new games? Not 2. Person 4. How many new games should I count? I'm not drawing it because it's going to get out of hand. I think we all agree on a 2. And when I consider person 5, how many games should I still count?
1.
New games that I haven't considered, only against 6. I'm going to squeeze it in here. Person 6, how many new games should I count? 0. Because I've counted all the games already played against 6. So now I'm trying to count all the games. So all I have to do is add them up. Add them up. So we need to calculate 5 plus 4 plus 3 plus 2 plus 1 plus 0. Now I know to you that seems so simple you don't even have to write it down, but you want to cater to all kinds of audiences. And to someone that's just learned addition, this is a big problem. Very challenging problem. So you want to explain everything in a lot of detail. Sometimes you feel it's too much detail. Then add more detail. Can't go wrong. Can't go wrong with more detail. Now I can just add this together to get what? 15? So 15 games were played. Am I done? No, that wasn't actually my question. The question involved 16 people. But I know a way to figure it out now. So now we can do the same thing with the actual 16 people. So I'll leave all this. So now let's do the same thing because now I figured out the problem. I have a plan for how to approach it. Now let's look at the actual 16 people. It's not so easy to spread 16 people in a circle, that's why I looked at 6. But I also don't have to do them all. Person 1, person 2, person 3, person 4, and all the way around to person 16. What time is it? Oh, good. So, when I'm considering person 1, how many games should I count? 15 games. When I'm considering person 2, how many games should I count? 14 games. For person 3, how many new games? 13. And we're seeing the pattern. For person 16, how many new games should I count? 0. Because it's the last person. So, I'm just updating my previous answer. Turn the camera. So I need to calculate 15 plus 14 plus 13 plus and so on, all the way down to 2, 1, 0. Just going to rewrite this. Now, yes, you can do it one at a time, but who wants to do that? Because the 16 could have very easily been a 32. Then it's not really practical anymore, or efficient. So let's write this. The 0 doesn't matter. 1 plus 2 plus 3 all the way to 15. Well, didn't we just do a formula for that? Now n, you can can say here n is 15. Therefore, it starts at 1, goes up by 1 every time. It fits the formula. So it's 15 times 16 over 2, which is 1. 120, oh, that's a nice number. So 120 games were played. Looking at a smaller problem, and depending on the calculation that needs to be performed, using other pieces of answers that I can use in this one, they're all coming together. And the more you do, the more experience you gain, the easier it becomes. There is another way to go about solving that one. And part of really understanding something and part of being an effective teacher is to be able to approach an explanation or a solution from different sides, because you never know which one would be most effective. So let's remember 16 people in a round-robin tournament, played every person once. How many games were played? Now our strategy is the same. Look at a simpler problem first. So first we looked at 6 people, for example, and you don't have to pick 6, just something manageable. And then the suggestion was, well, let's make a grid. You see, to look at the games in with a different diagram. So I'll have 7 columns, I suppose. Let's do it like this. And 7 columns here as well. 7, like so. Person 1, 2, 3, 4, 5, and 6. Person 1, 2, 3, 4, 5, and 6. Now there are variations in this as well, but something like, well, person 1 can play him or herself, so these squares are not going to represent a game. Person 1 can play person 2, person 3, 4, 5, and 6. And we do the same thing, just with a different diagram, really. It is the same thing, essentially. Where person 1, we consider 5 new games. Then person 2 can play 3, 4, 5, and 6. But we're not considering this one, because 2 playing 1 is the same as 1 playing 2. We can't count them twice. So we do get 4 new ones, then 3 new ones, then 2, then 1. But it's the same, just visualizing it different. And none of these are actually new ones we should count. So it's really just a different way of visualizing what's happening. Now you can come up with a calculation in many ways, but you still have 5 plus 4 plus 3 plus 2 plus 1 plus 0. You don't have to write the 0. So the calculation is the same. Everything, the underlying solution is still the same. Just a different way to visualize that some people might find more intuitive. So I just wanted to mention that, and then after that you can go about it with our calculation or some variation of that, but it's all essentially the same. So making a sketch or just drawing something, visualizing something makes a very big difference, surprising difference really. Though sometimes you feel you're not really doing anything, but just the act of drawing, just that process, somehow clears things up sometimes. The problem itself could be just a drawing problem, like the one following this strategy, draw a sketch. Now, the strategy of making a diagram is really integrated into many things. It's not a main strategy necessarily, though it could be. But it's always something that you should keep in mind, because somehow it helps me to just get into the problem and visualize what's happening. But in this case, we have just a diagram problem on its own. So example 3.5, I have this layout of dots. And the problem is asking that I draw lines connecting these dots so that all the dots are sitting on the line. All the dots are connected by one or more lines. No real rules other than that. How can you draw some lines? To do that, if you can only do so with 4 straight lines. So is it possible to join the dots with exactly 4 straight line segments? You're not allowed to pick up your pencil, you have to just make continuous line segments. So a line segment is one straight line piece, then you can turn around. So of course, if we have a lot of lines, it's easy. 1, 2, 3, 4, 5. 5 is easy. Everyone can do 5. Can I do 4? Now, the strategy really here is trial and error. Honestly, that's maybe a better label for the strategy. I just put it here because it's more of a diagram problem. But it is a little bit of trial and error. So, if you haven't seen this before, take like 30 seconds. See, play around with it. Can you do 4 lines? 5 is easy. Does everyone agree 5 is pretty easy? It's not a challenge. Can I do less? Now it becomes less obvious. So there are some other things that this problem is telling me, even though the topic is deceptive perhaps.
Oh,
You missed it. Misdirection.
there we go.
There we go. Okay, I'm just going to add some arrows. Everyone, round of applause for the effort. No, yeah, no applause. Sorry. A little applause. What was the key thing to keep in mind here? Really what this problem shows me more than anything else is to not make your own assumptions when the question doesn't say anything. The question doesn't say, I have to stay within that box, and I can only turn on one of the dots, things like that. I make that conclusion and limit myself, and then I can't find the answer. But if I think a little bit outside the box, there's a way to go past the line, turn over here, even there is no dot. It's fine. It doesn't say you can't do that. And then I can do it with 4 lines. And it's very easy, in this one especially, for me to just assume that I can't do that. And then there's no way to do it other than that. So it's nice to see stuff like this, to remind myself, don't feel restricted if the question doesn't restrict you. Yes?
And that's not tracing over a segment at all?
All you have to, let's read it again. You have to join the dots with exactly 4 line segments. You're not allowed to pick up your pencil. And you're not tracing. You can't, if you have a line there, you can't trace over the line again. They can intersect. So perhaps that could be misinterpreted, but by tracing over, meaning you can't go over the same line. It's not the same as intersecting the line.
I think it's just which direction the arrows are going. They should be going the other way.
I just do it in the way he drew it. Doesn't matter. That's the way he did it. As long as it's one
Middle one.
continuous piece, right? It doesn't matter. He happened to start from the bottom.
No, I started from the top.
Oh, you did? No way. You went up and then you missed, right?
No, I
Start
went
from the
top.
right.
Oh, I was totally not even looking. No, how did you do it then?
Just right.
Yeah.
Diagonal down.
The bottom line was either.
This one?
And then, no,
And
top
then-
right corner.
that
This one?
Yeah, change that one.
I swear you ended with this one.
No. Quite sure.
I'm watching the video later. You're on camera. Obviously, I'm not paying attention. I was so sure. Wow. All right. Mine still works though. Doesn't really matter where you start, as long as you don't lift your pen. I'm watching that video. Sure. Anyway, are there any other questions on that? Really, it's not something that I would put in a test, because there's no calculation, there's no real step process to follow. It does, however, show that I shouldn't make my own assumptions and read carefully. And if there's a word that, or a terminology that you're not sure about, we should definitely clarify that. So you see the question for what it is. Because you could limit yourself and not be able to find the answer. I'm going to jump around because it's more fun to 327, learn classic problems. 3.10. Excuse me. There are some problems that are just worth seeing. I have two of them. There are others. Sure, these two are good ones to see. I will read 310. Let's turn the camera first. Not that there's anything to see, but you never know. 310. As I was going to St. Ives, I think it's pronounced, I met a man with 7 wives. Every wife had 7 sacks. Every sack had 7 cats. Every cat had 7 kittens. Kittens, cats, sacks, and wives, how many were going to St. Ives? What do I do? Again, it's manageable. Classic, I didn't make it up. Any thoughts? Take that, we have lots of time. Even if we take time to think about each question we have to do, we'll still have Friday open for review. There's no rush. I want to take 30 seconds first for each person to think about it, because some people are faster than others. And you need to at least think about it. You don't have to finish the whole thing, but you're alone in the test, and there's only you. You have to get used to thinking about these problems on your own instead of waiting for someone else to say something. Not a long time, just 30 seconds, think about it. While I clear this. Totally fine if you don't find the answer, but just that starting to think about it makes a big difference. We are rolling in time. That's why I like this course. There's no rush. Sometimes maybe a little rush right now. Relax, think about things, let things develop in a natural way. Is that 30 seconds? All right, you were going to say something.
Well, just with the whole not reading into the questions and
Yeah.
whatnot, it only says I was going to say that. It doesn't say that the man and the wife.
What is the answer? One is the answer. I know, it's not a trick question, it's a question of, are you reading the question? Or are you just assuming, oh, this is going to be multiplication or addition, 7 and 7 and times and whatever. No, it never said that. How many are going to St. Ives? Only me. The fact that I met a man with 7 wives, it's irrelevant, they didn't go. Never says Anything like that. Only one. Only one. Read carefully. That's why I have those in there. They're fine. You feel a little silly. And you're reminded that you should read very carefully. And not assume anything. Not assume that, oh, it's going to be a multiplication problem, arithmetic, or whatever. You look at each question on its own. The very next one could be drastically different than it is. All right, now for the 311, I thought, let's remind ourselves of the process to go through in general problem solving. That stop, think, evaluate, proceed is just a variation on the original steps proposed by George Polya, but it's there in the introduction. There's lots of variations, but it comes down to the same thing. So in 311, you have two containers. One holds 5 gallons. The other holds 3. You can have as much water as you want. Your task is to measure exactly 4 gallons of water into the 5-gallon container. So how can we clearly explain each step that they may have glanced over to end up with 4 gallons of water in a 5-gallon jug? So you're going to have some sentences like a recipe to say, first do this, then do this, then do this, and eventually you'll get there. So what can we do first? So let's say here, do something, and then what do we have? What is in the 3-gallon jug? And what is in the 5-gallon jug? To clearly explain, that's heading here, what do we have at every step? So anyone that reads it, regardless of how tricky they find this, can follow your steps and understand exactly how to do it. What is the first thing to do following their solution? So the middle step is to end up with 2 gallons of water in the 3-gallon jug. So once I have that, like they did, they can fill the 5 gallons, pour 1 over, and then they win. Or they don't die. How can we get to that point, though? It's not silence, no. You guys are arguably the quietest 142 class I've ever had. It's because it's too easy, isn't it? Sorry, I apologize. In part 3, there will definitely be some challenging bits. So just hold on, it'll get better. What can we do? Do nothing? Or just let the bomb go off? This is life or death, people. It's a movie, but still. What can we do? Okay, I'll do the first one, fine. Fill the 5-gallon jug. Then we have empty and full. What do we do next?
Pour the 5-gallon into the 3-gallon. So then you
Pour the 5-gallon into 3-gallon. Then we have 3 here. This is a little bigger. And 2 there. What do we do next? Remember, you're trying to lay it out in so much detail that absolutely everyone who can read can follow it. What do we do next?
Do you pour out the 3?
Dump the 3. Dump the 3-gallon. Then we have empty. And still 2 in this one, right? What do we do next? Right? Put the 2 in the 3. Let's say transfer 2 gallons to the 3-gallon jug. This is the 3-gallon jug that now holds 2 gallons, and my 5-gallon jug is empty. Let me turn the camera just. What is the next step?
Fill it with 5 gallon.
Fill the 5-gallon jug. Oh, we're done now, right? That's the goal that we wanted, sort of the in-between goal. So then we have our 2 gallons here, and now a full 5 gallons. And then, like they did, let's say transfer 1 gallon to the 3-gallon jug, and we would be done. So now we have exactly 4 gallons, let's say here, measured. Does that make sense? Too easy? Sorry. Don't go and complain. The course is too easy. It'll get better. I'm just warming you up. Even though these things may be easy for you, not that it has to be, it may be, you can focus on how to explain things effectively. In your head it might be really easy, but you have to be able to write it down in a way that someone walks in, they read the problem, they can follow exactly what you're saying and understand every single step. So you can't make any jumps that you trust the other person, the reader will just fill in. Questions, comments? Should I put it in a quiz?
This one? Exact one.
Well, no, the numbers might be different, of course. I think there is one in the additional exercises that have different numbers. Too easy for a quiz? Make the quiz more difficult? That's what I'm hearing?
No.
No, that's not what I'm hearing? Yes.
Sorry, slightly, not this one. How do we know if we're exactly pouring 1 gallon into the other jugs?
Where?
Like, exactly the amount of gallons?
The only measurement I have is that if I fill it, I know it's 3. I can't eyeball it or anything. So if I fill that, I know it's 5. If I pour it over without spilling, I know it's 3 and 2. So in that way, by transferring, I can have an accurate measurement without there being any markings.
Okay.
That's the trick. Well, not the trick, that's a challenge.
Okay.
I think she was first.
Look at this sentence.
Oh, sorry.
At the end, how do you know you're putting 1 gallon?
Because if I have 2 in there, it's a 3-gallon jug. If I pour without spilling and fill it, there's only space for 1 gallon, meaning there has to be 4 in the other one. So often what before I had an example like this in the lecture, I would give people a question like this, and they would just say, oh, just fill it halfway, and just do this. Like, no, you cannot be precise when there are no markings on the jugs at all. So it's worth seeing, and then the numbers might change. My steps might change too if the numbers are different, but it's all a matter of just transferring and seeing, playing around with it until I make progress. Like in this one with a 3 and a 5, you can think, well, how am I going to get 4 gallons of water? It has to be in the big jug. I'm going to have 1 to get out of the big jug to be left with the 4, which means I need 2 in the small jug. Now how can I do that? So you can sort of work backwards as well a little bit, or just play around with it until it just happens, whatever works for you. There's a little bit of trial and error for sure. Any other thoughts on this one? Should we? No, tomorrow we can talk about the quiz. Just in case someone doesn't show up on Friday. Remind me to talk about the quiz tomorrow. Which ones have we not done here? 3, 12, yeah, we'll leave that one for the end.
3.25.
Let's just go from the beginning now and work through them. 3.6. 3.6. I think from the beginning, 3.6 we still have to do. Of course, these things are easier once you've seen the type of question. If you've seen these measurement questions before, yes, they become easier. The first one you see might not be the easiest. Same with 3.6. If you've seen that before, it does become easier. If you've never seen it before, then it is a little bit more challenging and we have to slow down. So the strategy says ask the right question first. Instead of answering the question in the problem, ask a smaller first question. Let's read numbers, 3.6. Arrange the numbers 1 through 9 into a square, subdivided into 9 smaller squares, so that the sum of every row, column, and main diagonal is the same. This is called a magic square. So let's make the layout, the diagram, 3 by 3 grid for numbers 1 to 9. The question is then, how do I fill them in so that when I add up every row, the answer is the same. Every column, the answer is the same. Diagonal, the answer is the same. So again, I have to understand the question first before I start doing it. Are there any issues with understanding what I'm trying to eventually show as my answer? We have to know what is our target in the end. How to do it, that's another issue. Any questions on what we're trying to do? Of course there are no questions. You guys say nothing. That's not true. You say something sometimes. And you came up pretty quickly to draw something. That's also a hard thing. Sometimes no one comes up when I ask. They sit there. You hear crickets. It's awkward. So that was nice, actually. Now, what people tend to do with this magic square is they just start filling in numbers and hope the universe just guides them to the answer. Is that a good strategy? I should have a strategy here. Universe guidance strategy. It's not. It's just not the way to go. Yes, you can get very lucky, but that doesn't help you for the next one. It doesn't give you any insight. So, let's ask a smaller first question. Not make the problem smaller, just a first question. Let's write it over here. First question that one could ask is, well, if every row and every column and every diagonal adds up to the same thing, what is that thing? What is that number that it adds up to? What does each row, column, etc. add up to? That is the problem. If I know that, maybe I'm taking a step in the right direction towards the answer. I don't have to take one step and be at the answer. I just have to move towards the answer. Now, in here will be the numbers 1 to 9, somewhere, I don't know where. If I add up all of these, I'll get, let's call it the total. If I add up all of these, I'll get the same total. If I add up all of these, I'll get the same total. So if I add up these totals, I will get 3 times the total. We don't have to get fancy with variables at all. I get 3 times the total, right? How else can I get 3 times the total? By just adding up all these numbers. 1 to 9 will also give 3 times the total. But adding 1 to 9 I can do. 1 plus 2 plus 3 plus 4 and so on until I hit 9 is? Well, you can use a formula. It's manageable to just do it one at a time. Regardless of what you want to do, what do you get? 45. So if I add them all up, I get 45, which is 3 times a row total. So what is a single row's total? Has to be 15. That information could move me much closer to the answer. So I know that I can't just choose these numbers and place them randomly. I have to place them in such a way that the row adds up to 15. Oops. That was supposed to be 15. This row has to be 15. This row has to be 15. This column has to be 15. This column has to be 15. This one has to be 15. This diagonal has to be 15. That's a lot of 15s. There's a lot of structure for that to happen. There's no randomness here. So, what I then should do probably is to see, out of the numbers 1 to 9, how can I take 3 of them to get 15? Obviously, there should be a lot of combinations like that. Can I make a list to see all the ways I can get to 15? That links with the very first question we did, where I have to systematically work through my list so that I'm sure I don't miss anything. I'm looking for a fair number of them. So let's make a list to see all of them. So I can have a 1 plus, I'm starting small, fixing the first 2 numbers. That's the smallest I can make them. There's only 1 of each. Thinking in the same way as 3.1, making a sequence. Start fixing the first things and then cycling through the rest until I've done all of that, then changing the next one, cycling through all that. Can I have a 1 plus a 2 and get a 15? Well, the highest third number would be a 9. That's only going to get me to 12. So the 2 is not an option. I'm fixing the 1. I want to move the 1. I want to essentially look at all the triples starting with a 1. Now the order doesn't matter, right? I'm just looking for a combination of 3. The order in which they appear doesn't matter. So can I do a 3? Why not? I just wrote a 3. Why not? I need an 11. I don't have an 11. Can I do a 4? No. Can I do a 5?
Yes.
Yes, then this one has to be a 9. So that'll be 15. So that's one of the combinations that will appear in a row, column, diagonal somewhere. Those 3 go together to make a 15. Then I stick with a 1 and increase this one, because swapping them doesn't give me anything new. I'm only looking for the combinations of 3. There's no order in here. I'll figure out which order they go in once I have them. 1 is 6 and a 8 would work. 1 is 7 and a 7? No, there's only 1 7. So 7's not playing with me. 1 and 8. I already have that one. So that's not going to work. 9. So that's all of them with a 1. Again, I'm not interested in the order, just the groupings of 3. This is making sense so far. Not at all? Which part's not making sense? That makes sense. Which part's not making sense? All of it?
I just found an easier way to solve it, so this doesn't make sense.
I'm interested to hear it, but I want to do this for other reasons. as well. But I'm interested to hear. 2 can go with what? 3 is not going to work, right? Then I need a 10. So 4 is the smallest one, and a 9. 2 and a 5 will give me 7, so an 8 would work. A 2 and a 6, could that work? Then I need a 7. And now once I do that, 2 and 7 would give me this one, 2 and 8 would give me that one, so I have all of them there. Everyone happy with that so far? All right, so I've started with a 1, I've started with a 2, let's start with a 3. What is the smallest next number can I do? I'm not going to look at 1 and 2, right? Because it would have come up here. So I'm only looking bigger. 3 plus 4, would that work? That's 7, so the other one has to be an 8. Can 3 be with any other number?
5 and 7?
3, 5, and 7. 3 and 6? No, because 3 and 6 is 9, then I would need another 6. I don't have that, I only have 1 6. Okay, so starting with a 3, there's also only 2 of them. Can I start with a 4? 4, I'm not looking at 1, 2, and 3 because it would have come up already, like it did there. And there. So 4 and 5. That's 9. So the other one has to be a 6. 4 and 6. No, that's 5. I already got that one. 4 and 7. 4 and 7 is 11, so I would need another 4, and I don't have another 4. So that's not going to work either. 4 and 8, that doesn't mean I stop everything, I just go to the next number. 4 and 8?
Yeah, I already have it.
4 and 8 would require a 3, but I already have it there. 4 and 9. That is a 13, which means the other number is a 2, and I already have it there. Does that mean I'm done? Is there anything missing in my list? I've only looked at the first numbers being 1, 2, 3, and 4. Should I look at the next one being a 5? Well, I'm not looking at 1, 2, 3, and 4 for that, so I can look at a 6, and I already have it there. 5 and 7 is there. 5 and 8 is here. 5 and 9. 5 and 9 is up there. So that's all of them. 6, would the same thing happen for 6? 7, 8, 9, they're already all in there. But I have to be convinced that that is my complete list. 2, 4, 6, 8 of them. What do I do now? Am I ready to just put them in and hope for the best? No, I don't feel ready. There shouldn't be any guessing. Let me just clear the spaces here. I want to guess. Because if I guess, then it doesn't really teach me anything for the next variation. That's similar.
Kind of like that foraging, where it's like one has to be like beside.
It is similar, yeah. What can I do as a next little step? If I'm not ready to just start putting things in, I'm not ready.
To be looking at how many,
Yeah.
each number show up.
I see some of them occur more than others. Why? Does that make sense? Well, yeah, if you look at this middle guy, is that what you're going to say?
Yeah, I was gonna say.
That guy is going to occur in every sum. No, not every sum. Almost every sum. Not in this side ones. But in how many? 1, 2, 3, and 4. Whereas a guy in the corner here only occurs in 3. Right? Column, row, diagonal. The guy over here only occurs in how many? 2. Column and row. So this middle one is a little more special than the others. It occurs more than any other number will. Is there something when I count them that occurs more often than anything else? 5 occurs more often than anything else. And therefore, it has to be the middle number. See how there's no guessing at any stage. And on top of that, more importantly, I can stop at any time and explain exactly what I'm doing and why I'm doing it. That is what I'm trying to do. That is what will make me a good teacher. Especially to kids, and things are shaky and they're not really concentrating. All kinds of things are happening. There can't be any jump, because if you make a jump and they don't follow that jump, they immediately conclude something's wrong with them, they're just stupid, and it's all over. You're not getting them back very easily after that. You have to take small steps that you can explain every single one of them. Everyone happy when I put a 5 in the middle? Now what can we do? We can look at the next numbers that are occurring most often. Like the 1, for example. The 1 only occurs twice. 2's occur 3 times. What else? So if I compare a 1 to a 2, where would they go?
Not in the corners.
1 can't go in the corner because a corner number is involved in 1, 2, 3 sums. And the 1 doesn't have that property. So 1 has to go over here to be involved in only 2 sums. So because of the symmetry, you can just put a 1 there. And then the rest will follow. Of course, this is not the only solution. You could have chosen to put a 1 over there, or there, or there. Doesn't matter. So I can flip it around and rotate it and I'll get the same result. Now once I've committed the 1 there, this has to be a 9. And I'm done with that one. It doesn't matter where you put that 1 as long as it's on a middle side square involved in only 2 sums. Does that make sense? Then, what can I conclude with a 1? Well, if this is a 1, this column has to have a sum that involves 1. So a 6 and an 8 have to go here. Does it matter which way they go? You want 8 in the top? Doesn't actually matter because I could just flip the board and have the same thing. But it does get rid of this one. See, the order didn't matter. Now you can focus on whichever number you want. Which number do you want to focus on next? Doesn't matter to you.
Or what do you want to do next?
I would maybe.
Although you can do the 4 next to it, doesn't it? You want to follow diagonal.
Yeah, it doesn't matter. I like to look at this though and fill this. What does this require? 8, 5, and something. Eliminating this one. Does this now require more? 6, 2, and 7. Excuse me. Where do I want to go? Diagonal. 6, 5, and 4. Does it fit with this column one? Is there a 492? Yes, there is. Here. And the last one has to be 3. Is there 834? Yes. 357? Yes. Again, there is never any jump that I'm making. There's never anything that I can't explain and teach someone how to do. I think it's important. More important almost than being able to just see the answer. We're trying to be more than just problem solving people. We're trying to be teachers as well. I think the next one in order is 3.7 that we haven't done. Is that right? All right, 3.7. Again, you should see, even though we're jumping around, you look at the whole collection of exercises in this subsection, it's obvious that some of them are very simple, some of them have a little more to them, and I really can't go in assuming the question is going to be one way, and then I'm not ready for it to be what it is. Like 3.6 was, there was something to it. It wasn't trivial at all. 3.7 may or may not be the same, I don't know. I have to keep an open mind. A certain convention numbered 100 politicians. Each politician was either crooked or honest. We're given the following 2 facts. At least one of the politicians was honest. Given any 2 politicians, at least one is crooked. Can it be determined from these 2 facts how many of the politicians were honest and how many were crooked? And if your answer is yes, what are those numbers making up the 100? First of all, yes or no, can we do it? Maybe the 100 seems big. And I think for many people, you let that 100 cloud your judgment. So let's make it simple. And maybe that reveals it a little better. Let's just take, how many people do you want? What's a manageable number? 10. 10's very a lot. 5. Let's consider, it's not that you can't do 10, but why go, if we're going to go down, let's just go down all the way. Let's consider like 5 people. And they give us those 2 facts, so that is a fact, those 2 points. Cannot argue with that. At least one of those 5 people is honest. So let's say I have person 1, person 2. Somehow I like arranging people in a circle. Don't know why. Well, I know why. There they are. They're sitting around a table. At least one of them is honest. I don't know which one. I don't really care either. But I know there is an honest one. Now, it doesn't matter which one. They're all the same to me. So let's just, as an example, let's say person 1 is the honest one. At least one means one or more. There could be more, but I know there is one. Let's say it's P1. Then it says, given any 2 politicians, at least one of them was crooked. So now it's under the category ask the right question. The right question is, or a right question is, can 2 people be honest? Now we've seen in our logical reasoning, what can we do? Let's assume that that is possible. Let's assume that that is the case. And then see what the facts are saying and see if everything matches up. Assume that 2 people are honest. I know P1 is, I just labeled them, they're all the same. So let's say P2 is the other honest person. Again, this is just one way of writing it out, but I want to not just be able to solve it, I want to be able to explain myself in a way that would probably cover anyone that reads this, so that they can follow it too. So now I have this one honest and that one honest. Assume that is the case. Let's compare that to the facts. Does it satisfy fact 1? Or does it agree with fact 1?
Yes.
Yes, at least 1 means 1 or more. Does it agree with fact 2?
No.
Well, I have to understand what fact 2 means. It says if I take any 2 politicians, in how many ways can I take 2 politicians? I can take these 2, these 2, these 2, these 2, these 2, these 2, many ways. Any one of those pairs, at least one of them is crooked. Why did you say no, it doesn't agree?
I thought no because if P1 and P2 were combined, it wouldn't satisfy it.
Right, so let's write it over here so it's a little higher. You have to be able to take any 2 politicians. So if we then say, well, but then if we take P1 and P2, they are both honest, and this contradicts, let's call it fact 2, sorry, not 1, 1 was fine, fact 2. What's my conclusion? That my assumption is not correct. Because if I go along with this assumption, something doesn't match up. Something contradicts something else. So, the assumption is not right. Let's say so. Our assumption is wrong. And we can conclude, well, we could have made the same assumption with 3 honest politicians. Would that have worked? 4? No, it's just worse. It won't work. So let's say here a similar argument with more than 2 honest politicians. A similar argument is the same, leads to the same conclusion, that it would contradict that fact too. So we conclude, I have to have 1 honest politician, conclude there is only 1 honest politician. Now, of course, this was for my smaller situation of 5 people. When I now go bigger to 100, what changes? Nothing changes in this case. It was just more manageable and easier to sell my argument, so to speak, when I had a nice manageable number of people. If I go to 100, it makes no difference whatsoever. Because, if I now say, oh, around my circle, I have person 1, 2, 3, 3, all the way to person 100. If I consider 2 honest politicians, because fact 2 says I have to be able to take any one of them, any pair, I can still take this pair and it would contradict fact 2. So it makes absolutely no difference when I consider 100 people. The argument holds in the same way for 100 I should say people. People. There is no difference. Sometimes making the problem smaller, there's a little difference in the calculation. In this case, there is no difference. There is no difference. So, there is only one honest politician, and therefore 99 crooked ones. It's not just about solving it. It's not just about having some insight and knowing the answer. It's about explaining yourself. It's explaining yourself. That is much more important. Any questions on this example? That was a much easier one than 3.6. It was just a little bit to write it out, but past that, it's much easier than 3.6, and I didn't know that going in. Let's turn the page. What is the next one? Spot a trick question. I sort of give it away, saying this is a trick question. Trick questions shouldn't say it's a trick question. But anyway, 3.8. 2 currently minted Canadian coins together have a total of $1.05. One is not a dollar. What are the 2 coins? What's this 3.8? I'll read it again. Sometimes we have to read these multiple times. Word problems. 2 currently minted Canadian coins together have a value of $1.05. One is not a dollar. What are the 2 coins?
A nickel and a dollar.
See, I gave it away because I said this is a trick question. I shouldn't give this a heading until the end, but how do I do that in a book? Unknown strategy. I don't know. It only says what it says. It says 1 is not a dollar. It doesn't say both. 1. 1. You ask someone that's not in this class. Ask a friend afterwards. Just say it quickly. You don't pick it up. You want to conclude, or you want to assume that neither one of them is a dollar. And then how do you do it? But that's not what the question says. So let's note, only 1 can be a dollar. So they are $1 and, now let's just say 5 cents, or whatever you want to write it. So easy, especially with trick questions, if you say them fast, or just verbally, and not lead in with this is a trick question, then it's very easy to fall for the trick. Very easy. I really just put 3.9 in there for no reason whatsoever. It's actually not a trick question. Any questions on this one? Before we do the next one. So again, it just points out what I've said before. Don't bring your own assumptions to the question. You're not going to know that a trick question is a trick question. It's going to look like any other question. And only if you read really carefully and think about the wording that's used, think about what it's asking, what it's telling you, does the trick maybe reveal itself. I also encourage you to just verbally say the next one to a friend, see what they say. Bob borrows $50 from each of his 2 friends. He only has 2 friends, I guess. He uses the money to buy a shirt for $97. He keeps $1 and gives $1 back to each of his friends, and now only owes $49. He gave 1 back. But 49 plus 49 plus 1 is 99. What happened to the missing dollar?
It's there the whole time.
It was missing. Where is it?
Well, he paid $97, but you're just subtracting the one that he gave back to each of his friends from the total amount that they gave him, rather than just having the fact that he spent $97, gave each of them $1, which would be 99
Not
plus
following
that
what
one.
you're saying at all. I am, but sounds confusing. I'll read it again. I don't understand the question. So I borrow 50 from each friend. So I've borrowed $100. And I've bought something for $97. Then I keep $1, give $1 back to each friend. So now I've borrowed 49 and 49. With my dollar, it's 99. So I'm $1 short. No? Yes?
Couldn't you just explain it from the beginning and just keep out the 49, like she was saying? Like, can't you just go 50 plus 50 is 100, minus 97, which is 3, and then it's 1, 2, 3, right?
I was just
There is
telling you,
no-
she was correct.
Yeah, it's just like explaining it is like, kind of,
Yes.
like there is no missing dollar, right?
Of course there's no missing dollar. Where is the part in the question that is trying to trick you?
Subtracting at the end.
In the question, where is the part that is leading us astray?
The 49.
Well, I wouldn't say the 49 because he does give $1 back, so he's borrowing 49 from each. It's that he keeps $1. He's keeping the 97 as well, that's irrelevant. So he is keeping $98 and giving 2 back, so everything is in balance. But when they say it as if there's a separate dollar, it makes you feel that, oh yeah, I have to add that dollar separately. Because they say he keeps $1. Yes, he also keeps the 97 that he spent on the shirt, but they don't say that. So it's trying to sort of distract you from the simplicity that's actually happening. Tell this to a friend. Just say it casually to them, quickly. See what happens. It's hard to pick it up if I don't preface it with trick question. So how can we explain it? That's maybe one way, many ways. Let's just say there is no missing dollar. But depending on your audience, it's hard to explain because they say, but 49 plus 49 plus 199, there's a missing dollar. And some people you just cannot convince. It's really challenging. I don't have the answer. It depends on the person. There's a lot of different ways that you might have to try to convince the person. Depending on who you're telling this to, there are people that you will not convince them that there is no trick. I don't know how to deal with those people, but if you try it, tell your friend. Your friend might be one of those people, and it can be really frustrating when you see something so clearly, you cannot convince them. It's really hard. Yes?
On the test, would it be okay to?
I'm not putting this in a test.
Oh, okay.
Trick questions are just for fun, not really for a test. It seems out of place for a test. I can put one in your test if you want.
No, I'm good.
Because it's tricky, and it's a trick question. Tricky. And tricky to explain. But it's something that you can have fun with, and also, if you tell the wrong person, sort of fall into a trap of frustration very easily. Which ones have we not done? 3.12 and the last one, I think. Section 4,
That's not on.
but we're not even done with the midterm.
No,
the
that's
quiz
what I'm
yet.
saying, no. Doesn't it say something?
Each part is a quiz. So
Yeah.
we're going to be done with the
I just
part.
thought 4 was part of this quiz, not next quiz.
No, it's in part 2. I can, again, put
I
something
think
on
I read it
yours.
wrong on the.
Oh, no, each part's nice and sectioned. Each quiz is a nice, different part. Very different. Alrighty, 312. We will talk about the quiz as soon as we're done with these, and neither one of them is very big, so we should have time. There are many ways to handle 312, and in 143 we go a little deeper into sequences, but for now, we're not doing that. I'm doing it in a specific way. That's definitely not the only way. Consider the sequence 3, 7, 11, 15, 19, and so on and so on. What is the number in the 100th position? Now, if you go and simply look at the sequence and finding the next number and the next one and the next one, going to 100 numbers will be incredibly tedious. So obviously we don't want to do that. I mean, you can, but I don't have time for that. So we have to find a pattern. And inductive reasoning is all about finding patterns. Seeing a link here between going one number to the next and continuing that pattern assuming it's correct. And with enough numbers, we saw with inductive reasoning, it's not always correct. But in this case, it will be because it's so simple. One that I like, that I really want everyone to have as a backup, just in case things get technical, and you have a sequence of numbers, it's always there. It's very handy. Look at the position of these numbers. First position, second position, third position. We've done it once, but I want to do it again because it's so useful. What am I now looking for? I'm looking for the number in position 100. Now let's make a little table. Not that you have to, but I'm going. So I want to relate the position with the actual number in that position. So I have the first number is 3, the second number is 7, the third number is 11, fourth is 15, and usually if you do 5, the pattern should be obvious. If not, then maybe it's really tricky. But for our level of difficulty, 5 should be more than enough. Now, I understand going from one to the next, I just add 4. That's simple enough. But that doesn't really necessarily help me to easily see what do I do to jump to 100. So often the first one is not that easy to work with, so let's skip to the second one. Now I've seen that to go from 3 to 7, I take the previous one and I add 4. Then to go from 7 to 11, I take the 7 and I add 4. But the 7 can be broken up into 3 plus 4. So it's 3 plus 4 plus this 4. Is everyone with me? Very handy little table. Then to get to 15, I take 11 plus 4. I saw the pattern here from one to the next. But 11 can be split up as 3, 4, and 4. So I have 3 plus 2 4s plus this extra 4. So here I have 3 plus 1. Let's write it like this. 1 group of 4. Here I have 3 plus 2 groups of 4. Here I have 3 plus 3 groups of 4. You can write it with a times symbol, with a dot, that doesn't matter, it's multiplication. So the next one's going to be 3 plus how many groups of 4? 4 groups of 4. Every time I add another 4. So the number of 4s that I have to add increase. So let's put a circle around this one, and this one, and this one, and this one. Looking at that, what is the link between the position that the number is in and its calculation?
Less than the number of 4.
If the position is 2, the number of 4s that I add is 1. If the position is 3, the number of 4s is 2. Position is 4, the number is 3. Position is 5, the number is 4. So the number of 4s that I add, like he said, is 1 less than the position value. Everyone happy with that? The number of 4s that I add in the calculation is always 1 less than the position. Therefore, the calculation for the number in position 100 is 3 plus 99 groups of 4. So handy. And the table somehow helps me. It makes it easier for me versus looking at this. Not so easy. Looking at this, I can handle much more complicated calculations and patterns. And somehow it becomes easier with this table. Any questions on where this guy comes from? I'm just looking at the pattern and continuing the pattern. And I can then calculate it as, what is 3 plus 99 times 4? Say again?
399.
399? And there you go. Very nice strategy. When I have sequences and counting, very nice, yes.
The questions like this on the test, are they going to be written or not?
Written or?
Multiple
No, they're all written.
So if we did it a different way though, is it?
As long as you explain it, it's all good. As long as you think, well, okay, this is maybe a little above little Timmy's level, but someone random comes in, by reading your answer, can they understand what you did? How, as well as what is the answer, how did you get to the answer, is equally, if not more important. Any other questions? It's definitely not the only way, no. But it's a way that I want to highlight because it's very useful, I find. All right, that was 312. We have the last one left, 315. And then we have to think about the quiz, I suppose. It's inevitable. It's coming one way or the other. Might as well try and get ready for it. 315. Again, it might be similar to that question. It might be different. I have no idea. As much as I dislike trial and error, guess and check, it does have a place. And by testing and playing around with things, it does sometimes reveal the answer. The problem is that kids cling on to guess and check for way too long. And I see in this course, people still want to do guess and check when there is a way that you can explain how you get to your answer. Oh, I guessed my way to the answer. It doesn't reveal anything for the person to then be able to solve the problems on their own. But it is sometimes useful. 8 marbles look alike, but one is slightly heavier than the others. Using a balance scale, explain how you can determine the heavier one in exactly 3 ways. So you have 3 opportunities to use the scale, put on whatever you want to put on, and at the end you have to be left with a single marble and say this is the heavy one, even though they look identical. You can't feel them or anything. The weight is so slight. Slight difference in the weight. How can I do it with 3 opportunities to weigh? Now I will say in this one, I'm not going to bother too much with the wording because it can get lengthy and tedious. I just want to understand how can we do it. And if you're not sure, because we're writing less, feel free to ask. How can we do it? So I have my 8 marbles. There they are. 1, 2, 3, 4, 5, 6, 7, 8. I don't know which one's heavier. So I can go first weighing, second weighing, third weighing. That's all I have. What do I do? Any other?
4 on each side.
Put 4 on each side. So I'm just going to indicate it like this. But you can draw a fancier scale if you want to. Does everyone know what a balanced scale is? Put it, one side's heavier than the other. Just check. So now, I don't know where the heavier one is, but one side is going to be heavier than the other. Let's suppose it's this one. That means I can eliminate the other 4. The heavy one's not in there. So now I have reduced it to 4 marbles, all the same, one is heavier. What can I do next?
Wait, 2 on each side?
Split them in half, weigh them 2 and 2. Because the heavy one's somewhere on one side is going to tip, let's say it's this one. So now I have 2 marbles. And then obviously what I do at the end, I have one more opportunity, put one on either side of the scale, and the heavy one is going to reveal itself. Everyone happy with that basic strategy? Everyone come up with that. Once you understand the question, it's not much of a challenge. All right. Now, of course, they don't stop there. They say, can I do it in exactly 2 ways? 2 ways. First of all, yes or no. And if you say no, well, then you're done. But you have to say why not, I suppose. And if you say yes, you have to explain the steps for how to do it. So the answer is yes, you can. But how? And it reveals, the key is the sort of an underlying theme in all of these. Don't read into it more than there is. Don't bring your own assumptions. How can I do it? Does anyone have any ideas? You don't have to do the whole thing, just the starting point.
3 on each side, maybe?
The problem is, I fall into that trap too. Reading it, you can easily come up with this. And you start to make, not you, I start to make the assumption that I have to put all the marbles on the scale. That's not true. No one said I have to weigh them all. I just have 2 opportunities to use the scale. I don't have to use them all. I don't have to weigh all the marbles. So why don't I keep 2 of them separate? I have no idea which 2 it is. Sorry, yes?
No, I have a different way of doing it, but I don't know if it'll work.
Well, let's do this and then.
Okay.
There might be another way. Just because I can't see it doesn't mean it's not there. And let's weigh 3 and 3. I guess thinking outside the box, but that's just another way of saying, don't assume one thing when it's not saying I have to put all the marbles on a scale at any one time. So I'm leaving out 2. I have no idea. The heavy one could be in there. No idea. And I'm weighing 6, 3 and 3. So let's say here, case 1. 2 things can happen. What are the 2 things that can happen?
It could be equal.
Could be equal, so they're balanced. Or they're not balanced. If they are balanced, what does that tell me? The heavy one's not in here, in the 6, and it's one of those 2. So then I'm left with 2 marbles, weigh 1 on either side, and I'm done. I know I'm not writing a lot, so let me know if I need to slow down, if you want to write notes or whatever you need to do. Does case 1 make sense? All right? What if they are not balanced? What does that tell me? It has to give me information. What is the information that I now have?
It's in one of the 3s.
It's in one of the 3. So I just picked the heavy one, the heavier side, so then I'm left with 1, 2, 3 marbles. Now you could say, but I have 3 marbles. I have only 1 more opportunity to use the scale. What can I possibly do?
Leave 1 out.
I can repeat this and leave 1 out. weigh the other two. Now what's going to happen? So let's say here case 2A is that it's balanced. What does that tell me?
The heavier one.
The heavier one is the one that's left out. So I'm left with a single marble and I'm done. What else could happen? They might. So I keep interrupting you. I'm very rude. One could be heavier, so let's call it case 2B, not balanced. But then I just take the heavy one. So I'm still left with just one. Left with one marble, and I'm done. I know this isn't a very clear description. You'd have to use much more in terms of words to really give it to someone and understand. But I wanted to do more of a discussion here, since it's time consuming to write all this out, and it's a little more than a quiz with a question. Yes?
Sorry, I'm just a bit confused on 2B. On how
So I balance two of them, one on either side. It's balanced or not.
Okay.
It's either tipping or not. If it's just staying still, that means the one I left out is the heavy one. If it does tip, well, that was the heavy one.
Oh, okay. Thanks.
Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Also, please visit me on my Patreon page if you want to support me in making further content. Thank you.